Hi everyone, we're going to take notes today. We're on page 13 and we're going to do Cornell notes. So we need to set up our page first. So I'm going to just draw a line straight across. And then another one right below that. And then a side one all the way down to the bottom. And then a side one over here. So this is where I put my name and the date. So it will be 10/29/20 tomorrow, or when you guys are watching this. So what we're going to take notes on is actually dealing with how or why we do measurements. So it's still measurement, but I think accuracy really ties this one together. So accuracy, let's put that up top. So our essential question for today is, why do we measure? And we measure so that we can do the same thing over and over again. If we want to build something over and over again, or we want to know the distance between two things, or how much things weigh to cook or bake or whatever. So there's so many reasons why we measure, but in order to measure, we need to do it correctly. And so in order to do that, we need to talk about precision and accuracy. So precision, if we look at our slide, is how close measurements are to each other. So I have an example there, second hands on a watch. So those seconds are really close together. They give us a very precise measurement. Whereas a minute or an hour or a day, they're not as precise. They're not as close together. So I wouldn't be able to give such an exact number or measurement. And then accuracy is how close you are to the actual value. And then that's really confusing. But this scale, I think, helps a lot. So we have this object that it's 100 grams. We know it's 100 grams. And my scale says on the first one that it's 100 grams. That's accurate because it's actually the value. My scale on the second one, though, says a different number. It's 98.89. Well, I know that that object is 100 grams. So my scale is not very accurate because it's not giving me the actual number that it's supposed to be. It's very precise. If we see that, it goes to the hundredth spot after the decimal, but it doesn't matter that it's super precise or it gives me very tiny measurements because it's wrong. So it doesn't matter. I need to have both. I need to have precision and accuracy together in order for them to give me a good measurement. So let's write these down in our notes. So let's start with precision, and then we underline it, and then I have my dash. Remember, my dash is my imaginary line. I'm not going to put my definition to the left of that. The definition just stays to the right. So precision, how close measurements are to each other. And I do want you to write the example. So for this one, our example was seconds hand on a watch. Now we could also say millimeters on a meter stick. Those are very, very close together. And then accuracy. Those are two C's, by the way. Accuracy. Accuracy is how close the measurement is to the actual value. For that example, we're going to draw our little scales because it looks good. So I'm going to draw my, and then that could be on a box. And this says 100, and this says 100. And then I'm going to draw another one. They're not the same size, obviously. I need to work on that. And then this one could be like 90 or 98.89. So obviously this one's accurate, and this one is inaccurate. So we have precise and we have accurate. Those things are super important when we are dealing with measurement. Another really cool thing that we're going to look at is in terms of maybe like a bow and arrow. If you shoot a target, if you get them all in the center, like you're supposed to at the bullseye, and they're all really close together, you're going to be precise and accurate. So that's that first one, number one. Number two, now they're all kind of around the bullseye, and you might be able to get one in the bullseye sometimes, but it's really spread apart. So you're hitting the target every time, but they're not close together. So it's not very precise. So you could maybe hit it, but they're not close together. And then number three, they're super close together, but they're not hitting the bullseye. So that's something that you could probably easily adjust for. You just aim a little down and to the left, right? And so then you get your bullseye. And then number four is just kind of random. It's not really around the target. They're not close together, so it's not accurate or precise. So we're actually going to draw that diagram, and you'll be just fine. So I'm going to draw some circles. I could totally make that bigger, but I'm not going to. It's fine. Okay, so I have my targets, and these ones are all really close together in the bullseye, and I'm going to put accurate and precise. Did I spell that wrong? No, I did. Good. Okay, so that one's accurate and precise. Number two, they're kind of all around the circle. We have one in the middle even. So they're kind of all over. So this one is accurate, but not precise. Okay, and so then we have number three. We have the dots up here, really close together, but not in my bullseye. So this one is not accurate, but it is precise. And then I'm just going to put neither. Is it IE? I don't know. So there's that. So we have our targets. And then we have two different kinds of measurement. We have qualitative and quantitative. Qualitative, is a quality of the measurement. So it's kind of describing something. So the color, if it's smooth or soft or fluffy or whatever, that's telling you about it. It's not something you can count or put a number to. There's no numbers involved with qualitative. So quantitative, that's a quantity. When you put an order in for Amazon, the quantity is how many of those things you're going to buy. Usually, whatever, you put that in. And it's a number. So if you use a ruler or a scale, or you're counting, or you do the temperature or something, those are all going to be numbers, and it's a quantity. So that's a quantitative measurement. So let's write those two down. Qualitative measurement. That's a really long 2 words. So that one is describing something. Whoa. Describing something. Let's write down some examples because I think that will be helpful. So, round, blue, the color of it, temperature, but not like a number temperature, so hot or cold. I liked fluffy. I thought that was a good describing word. So qualitative, and then we have quantitative. Measurement. And that is counting. Or numbers. So our example for that is using a ruler like we did in my room to measure the volume, or not the volume, the area. So we have scale, counting. It's a great example because it's the definition. I'll work on that. And then temperature. So all those things deal with counting or numbers. So we'll have those. And then the final thing that we really need to look at is bias. And so bias is that built-in error. So we saw that first scale up here, and it was off by a certain amount. And it's probably off every single time by this amount. And so what we can do is compensate for that. So if people have a bias, they're like, oh, I always think this way, or they always buy Nike shoes. That's a bias towards that thing. With measurements, though, it means it's a little bit off every single time. It's going to be a little slight error. So if you took your height and you're always wearing your shoes, well, you're off by your shoes every time. If you take a stopwatch and you click the thing, it takes you a little time to click the stopwatch. That adds time, and so you could compensate for that bias or that error. So let's write down bias, underlined, and that is built-in error. I feel like that is probably a good enough explanation or definition for this one. So these are the notes for today. We're going to be using these things and these words later on when we do actual experiments and measurement for those experiments. We'll obviously be, because of COVID and stuff, out of the classroom for a little while, so I might have you do some more experiments at home. We'll see how it goes, but thanks for watching.